Hello and welcome to LittleBIGPhysics, a series in which we try to figure out the mechanics of the world of LittleBIGPlanet from the ground up. Last time, we looked into how heavy Sackboy is, and just how much ice cream he's hiding under that soft-knit exterior. Today, we'll pose a new question related not to his physical features, but his physical capabilities. Sackboy is a pretty hardy little fellow, running all across the Magosphere without breaking a sweat. He's such a runner, in fact, that so long as there's nothing in his way, he always runs at the exact same speed. What is that speed, then? This will be a good opportunity for us to begin our foray into how things move in LittleBIGPlanet. As always, there's something of a catch to this scenario. We want to say how fast something moves, but what terms do we have to describe that? Let's take an inventory of the units we have so far. There's a length, the first unit we defined, which measures distance. Then we define the smass, which measures heaviness. We don't, unfortunately, have a unit for speed, but this is where we start getting creative. What units do you use when you describe the speed of something? We use units like kilometers per hour, meters per second, or miles per hour. Notice the per in each of those. A kilometer is a distance, so is a meter or a mile. Hours and seconds are time. To define speed, we can just say that if something moves at this speed for this period of time, it will travel this far. For example, if an object moves at 1 meter per second for 1 second, it will travel 1 meter. All we're missing, then, is a unit of time. Thankfully, that'll be the easiest unit of all. The LittleBIGPlanet uses the second, a very familiar unit, to measure time for different kinds of logic, so we can define speed with that. Now that we have units of both distance and time, we can define speed in lengths per second. You might have noticed I didn't start off by saying the LittleBIGPlanet has its own unit for this, like I did the last few times. Well, LittleBIGPlanet does have units for speed, but like the other units when we first started out, we don't know how big one speed unit is. Let's find out then. I'll keep things simple this time. What we're going to do is measure how long an object moving at 1 unit speed takes to cross a distance of 100 lengths. Here I have 2 floating microchips. One will begin moving to the right at a constant speed when I press the button connected to it. The other, which will stay in place, has a tag sensor inside with a minimum range of 50 lengths and a maximum range of 150 lengths, meaning its range covers a distance of 100 lengths. I could have made it longer, but then we might run into the issue of the outer unknown region that we had to work around a couple videos back. The tag sensor is connected to a timer, such that when the sensor is triggered, the timer will increase, and when the sensor is no longer triggered, the timer will stop in place. Just because I like clean numbers, I set the maximum time on the timer to 10 seconds. Finally, I connected this timer to Fort's signal display, which will show a number corresponding to how much time the timer has counted. At 10 seconds, the display will show 1, at 5 seconds it'll show 0.5, and so on. Now, we can just press the button and let everything work out on its own. The result is a time of 10 seconds times 0.7993, or 7.993 seconds, to cross a distance of 100 lengths. Divide 100 lengths by 7.993 seconds, and we get 12.51 lengths per second, which is the speed of one speed unit in-game. It's not a clean number, unfortunately, but sometimes things just don't work out. Now, though, we have the ability to convert between in-game speed units and lengths per second, which means we can just take measurements with whatever is easier and then convert it if we have to. It works out that measuring in in-game units is both easier and more reliable, so we'll make use of this shortly. Now for the main event, finding out just how fast Sackboy's little sack legs can carry him. We could take an approach similar to what we just did, using a player sensor instead of a tag sensor, but in the spirit of being creative and trying new things, let's do something different. Instead of timing Sackboy as he runs, let's measure his speed directly. We'll accomplish this with a contraption that automatically matches Sackboy's speed and displays a corresponding number. It'll be a floating object that uses a player sensor connected to a mover attached to itself. The player sensor will produce an analog output, making the entire object move faster the closer Sackboy is. If Sackboy runs at a constant speed, which he normally does, then the contraption will automatically match that speed. If Sackboy gets too close, then the player sensor will output a stronger signal, making the contraption move faster. If Sackboy is too far away, it will output a weaker signal, making it move more slowly. After a few seconds, it will reach a stable equilibrium at Sackboy's exact speed. Since the player sensor determines how fast the whole object moves, the signal output by the player sensor in this state is the proportion of the contraption's current speed to its maximum speed, which I set to 10 units. Thus, if we simply multiply the number on the display by 10, we'll get Sackboy's running speed in in-game units. Let's try it out. We get a reading of 4.189 speed units. The best part is that it's consistent, giving us the same number again if we fiddle with the setup by stopping and starting again or jumping. Now we can just convert this to lengths with the number we found earlier, 12.51 lengths per second, giving us 52.40 lengths per second as Sackboy's running speed, or about 5 times his own height every second. This would be the equivalent to a human running at around 10 meters per second, which is actually pretty realistic running speed, interestingly enough. Well, I suppose that's our answer. Sackboy runs at 52.40 lengths per second, or about the same speed a human would run if shrunk down to the same size. Let's just ignore all the physical complications and assume running at speed would scale directly with size. Interestingly enough, we also found last episode that Sackboy's density is about 0.9 grams per cubic centimeter, which is right around that of a human as well, whose density is usually about 1 gram per cubic centimeter. Our Sack friend might have more in common with us than we ever realized. One day, we might even find out if he's about as strong as we are, or if he's super strong for his size, like an ant. For now, though, we have more to explore on the subject of motion, where we'll explore objects moving at non-constant speeds next time. As always, I'm open to ideas, suggestions, and even corrections for anything I've done so far or might do in the future. In any case, until then, see you next time, and stay curious.